Okay, so now we're going to learn how to calculate probabilities for normal probability distributions. And specifically, we're going to focus right now on standard normal probability distributions. So this is the probability density function. So remember from the uniform probability distribution, we calculated that density function, which we used to calculate the probability. So this is the formula for it, for a normal probability density function, and this is the formula for the standard normal density function. So you'll notice that this is basically simplified from this. So remember, for a standard normal probability distribution, the mean is equal to 0, and the standard deviation is equal to 1. So if we took this probability density function, we plugged in those values, right? 1 for standard deviation, right? 1 multiplied by anything is just 1. Or it's itself, excuse me. So that's why this disappears, right? Because it's 1. 1 multiplied by anything is just itself. Up here, we see divided by, right, I don't know if you can see this, but this is divided by sigma, which again, if we assume is 1, right, anything divided by 1 is just itself, so that disappears up there. And then x minus mu, right, what's x minus 0, because mu is equal to 0, that's just x. So it's really just x, right, x, because x minus 0 is just x, x minus, divided by 1 is just x. So really this simplifies to, right, x squared divided by 2. You'll notice this is z because now when we standardize it, right, remember we learned about z-scores, that's what standardizing does. You convert it to a z-score. So that's where this all simplifies from this. Where does all this come from? This is a little bit more advanced math. You don't have to worry about that, where this comes from. And in fact, I'm not too concerned about you learning how to plug in values into this equation and solving. We're going to use Excel. I'll show you how to use the tables. You're more than welcome to use those. They're in your book. You can find them online. But I think it's a little bit easier to use it in Excel. Plus, Excel will give you more exact values than tables. Tables have some limitations. So again, what are we calculating? We're trying to calculate probabilities. That's ultimately what we're interested in. So okay, Kristen, we don't have to worry about that equation. You're going to give us Excel. You're going to give us a function and stuff we plug into it. Okay, we're going to get there, but you have to understand the different scenarios to know what to actually plug into Excel. So there's 3 different scenarios when calculating probabilities for normal distributions, right? We can find the probability that z is less than or equal to a given value. We can look at when the probability is between 2 values, or when it's greater than or equal to some values. So we'll go through these. Let's first learn about the first one, the probability that z will be less than or equal to a given value. So it's good to draw your distribution because I think that helps you figure out what you're calculating. So for all these examples that we're going through right now, we're assuming that we are working with the standard normal, right? Not this one up here. We're working with the standard normal. So remember, what's the mean equal to? 0, and the standard deviation is equal to 1. So you'll notice here, 0 right there, that's mu, right? The highest point, the central point is mu 0. So if we're looking at, okay, the probability that z will be less than or equal to a given value, let's say that we're looking at 1. We're interested to say that the probability that z will be less than or equal to 1. What is the probability? Well, where's 1? 1 is here on the curve, right, because we have 0, 1. And what is 1? 1 is 1 standard deviation above the mean. So we want this area under this curve, all of this area that's the darker shade of blue. So that's what we want to calculate. So we can calculate this a couple different ways. Like I said, you can use tables. So if you look in your book, you look online, right, we're looking for z because it's the standard normal we're working with. Z is 1.00. So if you scroll down here, you see 1.0, and then over here the 0.00, 0.01, and so on. This is right. What is to the right of the decimal point? So we have 1.00. So we have 1.00. If we scroll down to where this row and column intersect, it's 0.8413. That's the probability. So the probability that z will be less than or equal to 1 is 0.8413. We can also do this in Excel. So let's do this in Excel. So I already have all the solutions for all the problems for this chapter over here, but I'm going to do them separately for you. So if we want to calculate the probability for a standard normal distribution, we use the norm.s.distribute.dist.distribution. That's what we use. If we back up a little bit, you'll see norm. Right, you see different ones. We're going to use some of them, but right, again, make sure you use the S because it's a standard normal. So when you do the open parentheses, you see it takes two arguments, Z and cumulative. So Z is what we're interested in. Z is we're interested in 1, right, because we want to know everything that is less than or equal to 1. And then for cumulative, we want true, because what we want is the cumulative probability. We want all the probability down here all the way up to here. So we want this whole area. So that's why we use cumulative equals true. So we're going to enter and look at that, 0.8413, which is the same that we found in the table. So it's right there in Excel or right here in the table. So that's the first one. In the next videos, I'll show you how to calculate the probabilities when Z is between two values or greater than a value.